The material for this lecture comes from Chapter 2, and so make sure you read through the chapter thoroughly to prepare for the quiz. So we begin our study of philosophy by looking at the discipline of logic. What is logic? Well, one common notion of philosophy is that this is a discipline where really any opinion goes. There are no right or wrong answers, or at least no way to judge right from wrong answers. And while this notion is certainly understandable, especially concerning some of the abstract questions and issues that are dealt with in philosophy, this is not the way that we're going to proceed as we discuss philosophy this semester. Philosophy, rather, ought to be considered a rigorous discipline that uses the tools of logic where it is centered in the analysis and construction of arguments. And so when I say argument, notice that I don't mean a verbal fight. Some people might be allergic to this whole idea of wanting to argue for your position as though we want to have verbal fights. That's not what we mean when we talk about an argument. What we mean is a process of supporting a thesis, which is called the conclusion of your argument, with reasons, which are called premises. This is what an argument entails in philosophy. And so now premises usually consist of what are known as propositions. And a proposition is simply a declarative statement or declarative sentence that can either be true or false. So a common example is the statement that Socrates is a man. So this is a declarative sentence. The sentence is either true or it is false. So to have an argument then, you must have at least two propositions, one which logically follows from the other. We move now to talk about different types of arguments, and the first one that we're going to look at is a type of argument known as a deductive argument. So your textbook explains that when it comes to arguments, there are valid or invalid arguments, and a valid deductive argument is one that follows a correct logical form, so that if the premises are true, and then the conclusion must also be true if it's a valid argument. If the form is not a good one, then the argument is what's called invalid. Now I need to stress here that the form of an argument does not determine whether or not the argument is true. When we are looking at the form of an argument, we are looking at whether the argument is valid. The terms valid and invalid are not the same as true or false when it comes to looking at arguments. And this is a very important distinction to understand, and oftentimes new students to philosophy miss this point. And so I want to look at a few examples to help us understand what this distinction means. So the first type of argument, we start with the statement again, Socrates is a man. That's our premise 1. Premise 2, all men are mortal. Now if these two premises are true, what follows from the argument, the conclusion, is that Socrates is mortal. And so if we look at the form of this argument, the form looks like this. S is M. S represents Socrates, M represents man. Premise 2, all M are P. Conclusion, S is P. This is a logically valid argument. Now let's look at another example briefly. Premise 1, a penguin is a bird. Premise 2, all birds can fly. Premise 3, therefore, penguins can fly. Now, is this a logically valid argument? Well, to answer this question, we have to look at the form of the argument. So let's look at the form again. Premise 1, P is B. Premise 2, all B can F. Conclusion, P can F. If you look at this form, the form of this argument is virtually identical to the form above, which says S is M. You have, with the second example, P is B, same type of form. Premise 2, all B can F versus all M are P. Basically the same identical form. Conclusion, it should follow. So this is a logically valid argument. Now sometimes this throws students off because when you look at the particulars of the argument, you realize that the conclusion's not true. Penguins cannot fly. So how can you say this is a logically valid argument? Well, again, when we're trying to determine whether or not an argument is valid, we're not looking at the truth of the argument. We're looking to see whether or not the structure of the argument is valid. That's the important point when it comes to valid versus invalid arguments, is do we have a good structure? When it comes to the truth or the false areas of the premises, we'll have to look at that later. So valid arguments may have untrue premises, and what matters is the form, not whether or not the argument is necessarily true. Now we look at invalid arguments briefly. So premise 1 of this argument is my roommate, Sam Smith, is a mammal. Premise 2, all dogs are mammal. Conclusion, my roommate is a dog. So if you ask the question, is this a valid or invalid argument? The answer is, this is an invalid argument. Now this is interesting. We need to look at the premises real quick and see what makes it invalid. So if we look at the first premise, we notice that this premise is true. My roommate Sam Smith is actually a mammal. And if you look at premise 2, this is also true. Dogs are mammals. And so why is it that the conclusion is false? Well, the reason the conclusion is false is because the form or the structure of the argument is not laid out correctly, which is what makes it an invalid argument. So if we look at the form, S is M, premise 2, D is M, the conclusion, S is D. Well, the structure of this argument is not a good structure, especially when you're just looking at the different premises. The conclusion does not logically follow from these premises. And so what's wrong with this argument is not necessarily that it's false, or that's not what makes it invalid. What makes it invalid is that the structure of the argument is a poor structure. So now we go to the concept of a sound argument. And so to have a good argument, you need at least two things. First, the structure of the argument must be valid. That's the first thing that needs to happen for you to have a sound argument or a good argument. The second thing is that the premises must be true. So here is an example of what a sound argument looks like. Premise 1, if Mary is a mother, then she must be a woman. If you ask, is that premise true? The answer is yes, that premise is true. Premise 2, Mary is a mother, and so let's just suppose that we saw her give birth, so we know, we have reasons to think that premise 2 is true. So premise 2 is true. So what follows from this logically? It's that Mary is a woman. And so the reason why this is a sound argument is because it has both of the two criteria to make it a sound argument. First, the structure is logically valid, so this is a valid argument, but it's also case that the premises are true. So if you have a situation where the structure is valid and the premises are true, then you can know that the conclusion is also true. Now we will look briefly at some common forms of deduction. The first form is a form known as modus ponens, which is affirming the antecedent. Now, to affirm the antecedent simply means that you're affirming the prior. So we'll look at a few examples to see what this means. So, part 1 of modus ponens is if P, then Q. So now, what is the prior, or what is the antecedent? The antecedent is P in this argument. So premise 1, if P, then Q. Premise 2, we're affirming the antecedent, we're affirming the prior, so P holds. The conclusion, therefore, is P. So now let's put this into some propositions. So if P, so we'll fill in P with Mary is a mother. So if Mary is a mother, make that P, then Q, she must be a woman. Q represents the statement, she must be a woman. P represents the statement, Mary is a mother. So premise 2, we're affirming P, that Mary is a mother, and therefore the conclusion is Q. This is a structure of the argument known as modus ponens, and this is a valid form of deduction. The next one is called modus tollens, which this is denying the consequence, which means denying the following. So, if we look at our structure again, if P then Q, what you're doing is you're denying the consequent, that which comes later. So premise 2, you're saying not Q. We're denying Q. Therefore, the conclusion is not P. So again, we put this into the sentence form. If Leslie is a mother, then she is a woman. But now we're going to deny the Q. Leslie is not a woman, but a man. And so what follows from that, logically follows from that, is that Leslie is not a mother. So this is known as modus tollens. Next, we look at the disjunctive syllogism, which is denying the disjunct. And so here you have a situation where you have premise 1, either P is true or Q is true. Premise 2, not Q is the case, and so the conclusion is P. So here is an example of how this structure looks like in sentence form. So premise 1, John is either a bachelor, P, or a married man, Q. Premise 2, we know for certain that John is not married. So we know that not Q is true. So what follows from that, if John is not married, that he must then therefore be a bachelor, P. This is sort of the either or disjunctive syllogism. And so that could work either way too. If you deny P, then if it's not P, then the conclusion is that it's Q. The last one that we're going to look at is reductio ad absurdum. This is reducing the argument to a contradiction. So the way this works is you assume, say, your opponent's position or a position that you're trying to refute for the sake of argument. So you assume A for the sake of argument. 2, you logically deduce a contradiction from A. And then third, this proves that A is false, since a contradiction cannot be true. Now, these types of arguments are generally more complicated, but they are important, especially when it comes to arguments for the existence of God. And so you take your opponent's position for the sake of argument, and you want to show that your opponent's position eventually leads to some sort of contradiction. And so your book offers the following example to show what this type of argument might look like. So premise 1, let's suppose for a moment that you're correct in saying that there's no such thing as a self. So this is you talking to your opponent. Your opponent argues that there's no such thing as a self. There's no such thing as a self who acts, who thinks, who has a personality. And so you say, okay, let's assume that you're correct. We're assuming not A. Then you move on to what this entails, if that's true, what this entails logically. So if there is no such thing as a self, then there is no one who ever acts. And so what you're saying is, if not A is true, then what logically follows is not B. there is no one that ever acts. And so if that's true, then you can move on to step 3 of the argument. But if no one ever acts, then no one can ever utter a meaningful sentence. And so what you're saying here is if not B is true, then it also follows that not C is true. And the reason why this wouldn't be true is because uttering a meaningful statement is a form of action. And so if there is no self, then there is no one who ever acts. But if there's no one who ever acts, then it follows that there's no such thing as meaningful statements. But now you move to step 4, and you show, but you have purported to utter a meaningful statement in saying that there is no such thing as the self. That in itself is a statement, which means that there is at least one meaningful statement, which is showing that C happens to be the case. But now we come into a problem because according to your argument, there is and there is not at least one statement. In other words, if you look back through the progression of the argument, we see at one point in the argument not C is true, but we see that in another place in the argument C is true, and that's a contradiction, which means the conclusion is that it must be false that there is no such thing as a self, not A, which by double negation yields A. Thus, we have proved by reductio ad absurdum that there is such a thing as self. Now, on page 17, Pullman points out 2 forms of invalid arguments, which are denying the antecedent and affirming the consequent. So make sure that you read those sections carefully because those might be questions that come up on your quiz. So make sure you understand the different forms of deductive arguments, both the valid forms of deductive arguments and the invalid forms of arguments, so that you can prepare properly for the quiz. Now let's move on to inductive arguments. These are different from deductive arguments in that they do not guarantee the truth of a position, but only the probability of it. And actually, for most arguments in philosophy, there is not certainty, only probability. But this is not necessarily a bad thing. In fact, as David Hume points out, most of life entails an intuitive grasp of probability. So when I woke up this morning, I drove to a local coffee shop. Why did I do that? Because, it's possible that the local coffee shop might have been shut down or just went out of business. And so if that were the case, I would have wasted my time driving across town to grab a cup of coffee. Well, we do not live in a world where we just simply follow mere possibilities. We live in a world of probability. That's the way that we function all throughout life. So it certainly is possible that the coffee shop would have been shut down when I arrived there this morning, but that's not probable. And so if it's not probable, I shouldn't act as though it's going to happen. And so many of the actions that we take in life can boil down to our intuitive grasp of probability, and that is what makes, that's what inductive arguments are really all about. And so when it comes to induction, we do not talk about these arguments being valid or invalid, and we don't talk about them being sound or unsound. Rather, inductive arguments are either strong arguments or weak arguments. They are cogent arguments or implausible arguments. So I would just encourage you, look at page 18 to just see some examples of the structures of inductive arguments. But this is the difference between inductive and deductive arguments. So now when we're doing inductive reasoning, this is a process of arriving at conclusions from a series of specific pieces of evidence. So here's one way that an inductive argument might look. We might take examples, statistics, and testimonies, and other types of lines of evidence into our data set. And so as we have this set of evidence, we use those to form some sort of conclusion. And remember, the conclusion that we form from these different lines of evidences are probable conclusions, not certain conclusions. So here are just a few examples. The statement, all swans that we have seen have been white. So that's the evidence that we've used. All the swans that we've seen have been white. Therefore, the next swan that we see will probably be white. Notice it's not certainly going to be white because there might be swans that are different colors. But based on what we've seen in the past, it allows us to make probabilistic conclusions. Another example, every life form that we know of depends on liquid water to exist. Therefore, all life forms probably depend on liquid water to exist. Again, this isn't certainly true, but this is just based on our experience, based upon the evidence that we have. These are the probable conclusions that we come to. We might be able to write out the argument like this. Premise 1, 90% of humans are right-handed. Premise 2, Joe is a human. What is the conclusion? Joe is probably right-handed. If Joe is just selected from just a random sample set, we would probably say that Joe is probably right-handed, although he might be a part of the 10% that is left-handed. But this is how inductive arguments work. Now we move to abductive arguments. This is the last type of reasoning we will consider in this chapter. Abductive reasoning is really an inference to the best explanation and was first formulated by the philosopher Charles Peirce. Abductive reasoning also deals with probability just like induction does. But the difference is that abduction judges a position or hypothesis by its explanatory power. So here's an example. If I walk outside of my house and I notice that there is a mud puddle in the driveway, I might want to know, what is the explanation for this mud puddle? How did this get here? And we notice just at the beginning, as we start to brainstorm possible explanations, there are many explanations that can explain this data or this event that we're seeing. For example, it could be the case that the neighbor boys down the street had a water balloon fight and they created a puddle in my driveway. It might also be the case that I have a broken sprinkler in my lawn, or that I have a backed up septic tank, which would be very unfortunate. Or it could be the case that there was rainfall last night, and so when I came out this morning, the puddle is the result of rainfall. Any one of these explanations are possible explanations. Now, if we want to know which one is true, we need to be detectives and go out and try to figure out what is the best explanation considering all the facts. And so if we go out and we act like detectives and we want to see what is the best explanation out of these four, we might go out and let's say we don't find any broken water balloons. Well, if we don't find any broken water balloons, that might make it less plausible that the water balloon explanation is a good explanation. Let's say we go look at the sprinkling system and it seems like that's all intact. Then that probably would make us think that, well, it's not the case that it was the sprinkler head. And then we look at the forecast and we notice that last night there was reports of a thunderstorm. And so when we take that line of reasoning in, then what we see is that that's probably the best explanation, though it's not the only explanation. And so we use abduction whenever there are multiple explanations for the same sets of facts. And this is typically the type of argumentation that's used by detectives and scientists. And so that's abduction. So again, this chapter we looked at abduction, deduction, and induction. These are the major types of arguments. And I went through them very briefly, so really do make sure that you go through this chapter thoroughly, especially through pages 21 through 27, which I didn't cover. So anything from this chapter, just remember, is fair game on a quiz, and you will want to make sure that you have a good understanding of the material.